seeing behind me is all that has gone into the expansion of Makerspace at Paterson Public Schools. We started with the regular 3D printers, and then we moved on to creating bigger Makerspace labs with 3D laser printers, the Glowforge printers, the real industrial size, large 3D laser printers, and students started creating engraved products with the 3D Glowforge laser printers. And now we are moving into the area of robotics and electronics. And just want to show you some of the stuff that has just arrived, and we will ship all of these items into different schools. So far there are 13 Makerspace sites in the district, and some of these now will cater to other, because the 3D printers and 3D laser printers, because of the high intensity electricity and power involved in that usually, we have kept it for upper grade levels, but for lower grades from kindergarten through 8th grade, we are expanding into the areas where you'll see that now they will have the STEM and STEAM focused electronics and creativity focused projects created right here in the classrooms. But before I get into it, let me show you the items in this pile and their prices. That should give you an idea how much of the investment you might be making. The cost that I'm showing you here is for 6 robotics setups in 6 separate makeups. It doesn't include the 3D printers or the 3D laser printers, which is a totally separate part of the Makerspaces. An average MakerBot 3D printer will cost you around $600 plus another $200 for the filament per site. The Glowforge laser printer, on the other hand, will cost you around $8,000 with all of its filters and exhausts, plus another $500 for the premium account that is necessary to run the machine and the materials required to laser print. What you're looking at on this invoice are the robotics equipment for 6 different Makerspaces. This includes codable microbits. These are teeny tiny computers. That cost about $1,954. And then you have the Brick Lab code set, which is also a sort of these are the circuits that can, in the form of bricks, which you put together, and they perform different functions. And then you have the magnetic building tiles. These are also programmable, codable tiles, that you put together and in different forms and different shapes, and then you can also make them perform different functions. And then we have this different paper circuits, wherein the students can create different shapes of circuits, electrical circuits, electronic circuits, and that is that's another item. And finally, we have the class sets for these electronic circuits, costing another $1,235. So overall, if you look at that, so these are the prices on this side that you're looking at: $1,954 for the coding microbits, and this is probably the most expensive of these items, and the rest are relatively lower priced items. This is the first of these items. This is called a robotics invention kit. This actually part of a microbit. Many of you might be familiar with microbit. Microbit teaches students to code and to program different items and actual items on their computers. They can use Chromebooks. They can use even iPads to create different kind of movable items in robotics electronics. So we will be creating, for example, here they're giving you an option to create a crane. So a couple of things go into creating a crane of this kind. We have here, first and foremost, is the actual microbit kit. So this is a microbit kit. If you look inside a microbit kit, these are, I believe, 10 of these microbits. These are small computers. So the microbits are here, and these are programmable little computers, you can call them. You can use Chromebooks to program these, and there's free programming application available at MIT.Scratch. They use Scratch code, what they call the block programming language for this. So they will attach these little computers to these devices. So this is the basis of this device. So this will be the second component of creating a crane with all these electronics that are required to connect all of these items to this one. This is what they call a STEAM school kit. They have all of these different components to create various kinds of objects, movable objects, with the help of these devices that I just showed you. So they'll be using the actual microbit computers. They'll be using these little programmable computers, and they have the batteries in there, and then they have the chargers. All of these are part of the microbit that we purchased, and then these are the basis. These are the actual board to connect these microbit computers onto these the third component, which are the actual arms and legs for different items. So we'll be creating various items, and it does show that it's good from kindergarten through 8th grade. That's great. So this is all one part. So we have 1, 2, and 3 components that will go into creating these programmable, movable computers, the different objects. Then we have over here what they call the cubelet. This is another robotics item. Cubelet. These are what they call the block robots. So the way they look like, these are little blocks here. So these are magnetic blocks that have, in some cases, they have these little wheels at the bottom. See, these are, so they will be moving in the direction they are programmed to move. And then on the other end, they have these little cameras. So the cameras will see if there are any obstructions in their path, and they're gonna start moving. So the students will be creating different kinds of movable block robots, again with the help of programming them. And this is a simple charger for these devices. So we have all these charging devices, and they have the charging cables for these cubes. So once these are charged and they are programmed with the help of microbits, they can program to move a specific path, and that is where the learning happens. This is why this is a highly engaging and interactive. These are collaborative activities, by the way, because the students will work in groups, and they'll be collaborating with others to find out what kind of pathways they should be designing for these cubes to move. And if I show you here, these are the items that we just received. So far we'll be sending these items to 6 different schools for their Makerspace expansion program. Like I said, we've already sent out the 3D laser printers and the 3D printers, and finally this is something I'm so excited, and the students, once they start working with these things, they get super excited with these. This also is a robot. This is a movable robot. It's called a Dash. It comes with a full-fledged curriculum with it. Again, it's pretty large size, and there are different sizes of robots. I think the small one is probably called Edison, but this is a pretty big robot if you look at that. So this again has got the wheels at the bottom. It's got the camera at the front, and the camera is movable 360 degree. The students will program these little robots to go in a certain path. So this will teach them programming languages. Again, we're going to start with the block programming language like Scratch, and then move on to Python and C++ in the upper grades. But we are super excited to have all of these things coming up. And over here, you see that these are some of the new 3D printers that they are still in the boxes. I'm not going to show these boxes to you, but I've shown you the part of the expansion program where we have the robotics and electronics expansion program of our Makerspace. I'll show you more once they reach their classrooms. I'll show you how students are using them. Look, this is a huge operation This is all is the Paterson Public Schools central warehouse, and all of these items are received here, and from here they're shipped out to different schools. So this is the STEM technology, whatever you want to call it. This all is part of that. And I'll see you in schools soon.